Hi, okay, we meet again. This is my video number 6. Yeah, this is my video number 6. Okay, so in this video I'll talk on the properties of the cross product, the volume of the parallelepiped, and I'll give you some exercise at the end if I have. Okay, so let's begin this thing. So the properties of theorem, the properties of the cross product. Okay, the properties of the cross product. So if A, B, C are vectors, and alpha is a scalar, then we have these properties. Number one is that A cross B, this is equal to minus B cross A. Number two, we have alpha A cross B, this is equal to alpha A cross B equal to A cross alpha B. Number three, we have A cross B plus C, A cross B plus C, this is equal to A cross B plus A cross C. Number four, we have A plus B cross C, this is just the same as A cross C plus B cross C. Right. And number five, we have A dot B cross C, this is equal to A cross B dot C. And number six, we have A cross B cross C, this is equal to A dot C B minus A dot B C. Alright, so let's prove one of this. I think you can do the rest of it. It's not very difficult. Just choose A, vector A with component A1, A2, A3, and B, B1, B2, B3, and C, C1, C2, C3. You can show all those one by one. Let me show one of them. Proof number 5. So number 5, we want to prove that A dot B cross C is equal to A cross B dot C. Okay, so if we let vector A with component A1, A2, A3, vector B with components B1, B2, B3, and vector C with components C1, C2, C3. Okay, so vector C with components C1, C2, C3. So therefore we have A dot B cross C, A dot B cross C. You can find what is B cross C first, and then dot with A. So this you will find that A1 B2 C3 minus B3 C2 plus A2 B3 C1 minus B1 C3 plus A3 B1 C1 minus B1 C2, sorry, minus B2 C1, okay, and rearrange this. So you have one, I think, A3 B1 B2 C1, right? Okay. So rearrange this. So you have A2 B3, A2 B3 here minus A3 B2 C1. Okay, from here we factor out C1, from here we factor out C1 and put it together. So plus A3 B1 minus A1 B3 C2 plus A1 B2 minus A2 B1 C3. Okay, so we have here, this is A2 B3 minus A3 B1. Everything in the bracket there is A cross B, and this is the element of vector C. So we have A cross B dot C. So note that the A dot B cross C, we can evaluate this by using a determinant of a matrix. So at the first row is vector A1, A2, A3, and then B1, B2, B3, and then C1, C2, C3. Okay, so if you are given 3 vectors to find A, just use that. Yeah. For example, if you are given A with components, let's say 1, minus 1, 2, vector B with components 2, 1, minus 1, and vector C with components, let's say minus 1, 2, and 1. Okay, then if you want to find A dot B cross C, okay, just write in the matrix form, determinant of the matrix with element, first row is element of matrix A, so we have 1, minus 1, 2, then 2, 1, minus 1, then minus 1, 2, 1. Okay, I think you can find this. It's not difficult to find. Okay, you can find it yourself here. Okay, now we look at the determinant of this matrix. Yeah, the determinant or the, so what we're going to have, get the volume of parallelepiped. So parallelepiped is what is parallelepiped? So we have a base. Let's say we have a base that, and we have another vector here. Okay, so let's call this vector as B, as C, as A. Okay, and so this A, so let's zoom a little bit. Okay, so we have those parallel to A, that, so we have again parallel to C, that, and then parallel to B, and then parallel to A. So that's the parallelepiped. So how to find the volume of the parallelepiped? Yeah. So the volume of the parallelepiped is given as, so let's say V is equal to A times H. So A in this case is not this vector A. Yeah. So H is the height of that. So this A, this is H. Okay. So you can project this onto y-axis. So let's say this is x. So if you take that as y-axis, say, so H is given here. Yeah, where theta is the angle A and that axis. So what you can find there, so we have, so where A is B cross C, magnitude of B cross C, and H, if you look at here, this is A cos H, A cos theta. So A cos theta. So the volume of matrix of the parallelepiped, therefore we have A, there's a B cross C, H is A cos theta. So that gives us A dot B cross C. Then if this vector A, A dot B cross C, if this is equal to 0, then the vector A, B, C are coplanar. Coplanar means we have these three vector A, B, C is on the same plane. So let's say if you have this plane, yeah, let's say if you have that plane, so A, B, C is, this is A, could be, this is B, could be, this is C, could be. So A, B, C. So on the same plane. So we don't have the volume. Okay. So look at the simple example. If you're given A example, if you're given vector A as 1, 4, minus 7, and vector B as 2, minus 1, 4, and vector C as 0, minus 9, 18, show that 18, okay, show that A, B, and C are coplanar. Okay, so what we need to do is just find what is A dot B cross C. If you proceed this, you'll get 0. So therefore, ABC is coplanar. Therefore, A, B, C are coplanar. Alright. Now, let me give you one more theorem. If AB are two vectors different than 0, and vector angle theta is the angle between vector B and A and B, okay, then A cross B is given as A, B, sine theta, and n in the direction of A cross B. So this n in the direction of A cross B. Okay, and of course n is orthogonal to vector A and vector B. So if you have let's say if you have this vector A and B, this vector A and vector B, and then your n is in that direction. This is your n in direction of A cross B. Yeah, unit vector in the direction of A cross B. So it's not difficult to prove. Yeah, if you look at those things, it's not difficult to prove. We know that n is A cross B over magnitude of A cross B. Now, of course, you can rewrite this thing. So we have A cross B is equal to A cross B n, and A cross B is and magnitude of, you have magnitude of A, magnitude of B, sine theta, and n. Okay, so I think I will end up this video with a simple example. Basically, I just give the question, you do the rest. Okay, if A given as -4, 1, -1, and B 0, 5, 3. Okay, so write AB as a multiplication, write A cross B as a multiplication of its vector unit. So which means you want to write A cross B in that form. Okay, so how to do this? Of course, you need to find A cross B. Okay, you need to find A cross B. Okay, then find the magnitude of A cross B. Find the magnitude of A cross B. Okay, then from there you can find what is the normal vector in the direction of A cross B, which is given as A cross B over A cross B. Okay, and then number 3, you can find the angle theta, which is the angle between A and B. You can find this thing. And then 4, just write A cross B as a you can write A cross B, A magnitude of A, magnitude of B, sine theta, n. Okay, you can write that form. Or you can also use this formula here, A cross B n, much easier. Okay, so with that properties of cross product, I stop here for this video, because in the next video I'm going to talk on different topic equation of line and plane. So I'll stop here for a while. Okay, see you in the next video. Bye.